yourself, and then, you're the scientist, who's on deck? You're sitting there, on deck.
It's gonna be interesting.
Welcome all scientists to, our seminar and conference, and what we discovered about the candle.
Okay. Okay. My name is Sawyer Black, and I did some experiments and research on the candle. So one of my greatest observations, I think, is this one, number 5. The material that makes up the outside is very easy to get off of the candle. When you scrape the candle, the outside chips off and the material turns into a flaky substance. Right. And for my second observation, it is number 15. When you place the noodle near the flame, the dried noodle will draw the flame near the noodle. That is my second observation.
I've never seen that. Is that what happened?
Yeah, that's what happened with mine.
I've never seen that.
But it wasn't like super like exaggerated, but it was like,
Really?
yeah.
Really?
And then,
Before it got into the flame, it actually drew the flame toward it.
yep.
Wow.
And then I'm gonna do my second observation. I hope you can see
So,
it.
you already did 2 observations. You're
I
gonna do
mean,
one
experiment. Yeah,
Okay.
I'm gonna do my second experiment.
Yeah.
All right, there we go. Oh, never mind. Okay, I was funny. Okay, for my second experiment, I took 4 beakers at 4 different sizes. Every time I set the candle on fire for 10 seconds before placing a beaker over top of it. The largest beaker made the candle last 17.18 seconds. The second biggest beaker made the candle last 13.57 seconds. The second smallest beaker made the candle last 11.77 seconds. And the smallest beaker made the candle last 7.31 seconds. And then I made a little graph right here. And on the y-axis, I did seconds, and it goes up to 17 seconds. And then on the x-axis, I did the sizes of the candles. That, yeah, the volume that goes up to 1,000 milliliters.
Hi. Can you tell us, as a scientist, why do you think you got these? That looks like a pattern. Why
Yeah.
do you think that happened?
I think it happened because the smaller the beaker, the less room the candle had to. The less room the candle had to. Hold on, I'm trying to figure out how to say this. No, the bigger the candle, the more room it had to keep the gases in the area, so it would stay on fire more. And then the smaller the candle, the less room it had, so the gas would put it out.
What's your theory about why the candle went out?
Probably because the elements in the air, there wasn't enough elements in the air or something like that.
Where do you think they went?
The beaker absorbed it, and it turned into like a moist thing.
Show our appreciation for our scientists. Next on deck. On deck right here. Hey, thank you. I love this. Introduce yourself, and you're a scientist. All you do is tell me what you did.
Hi, I'm Euritz in Alaska, and I'll be telling you about my candle experiments. Sorry, it's really bad handwriting, but so my first observation is number 5, and I wrote, once the candle was lit for the first time, the string turned completely black and brown and started to create a puddle of wax at the tip of the cone. After the candle was turned off, the string was no longer hot.
As a scientist, what do you think when you heard that observation? Did you get a picture of what was going on? A clear picture? I like that one very much. All right, next one.
Then I did
Try to speak up as loud as you can, okay?
Then I did number 15, and I said the frozen candle's flame is 10 centimeters high when it is lit, and it gradually gets smaller, whereas the unfrozen candle is only 5 centimeters high in flames when it is lit, and it stays at the same height the entire
Wait a
time.
minute. You're telling me the frozen candle had a taller flame than the room temperature candle?
Yes.
Wow, I didn't know that either. All right, experiment.
And
doing?
Yeah. For my experiment, I'm going to choose the first one, and I did an experiment between two different candles, a frozen candle and an unfrozen candle. And what I did, my question was, will the candle turn off faster if the beaker has a different substance around the beaker? So I had 3 different beakers, and the first beaker, I covered it in water and baking soda, and it took 10.06 seconds for it to turn off on the unfrozen candle. And then the second beaker was water with BRB, and it took 7.1 seconds. The third beaker had oil, and it took 40.99 seconds. And then for the frozen beaker, I did the same thing, and the baking soda one took 6.79 seconds. The BRB took 24.82 seconds, and the oil one took 40.33 seconds. So,
What's your summarize that for us?
So in conclusion, the frozen candle took the longest for it to burn out.
Okay, so it took the longest before it went out, right?
Yes.
What's your idea about that?
I just think because the candle, the wax itself was frozen, so it took longer for the flame to melt the wax.
So why would that make it longer for it to go out? What do you think? And we're just guessing, okay? We're guessing.
I'm thinking because of the change in temperature.
Because what?
The change in temperature.
Change in temperature? What do you got, fellow scientists, any ideas about this? I've never seen anybody do those experiments, for sure. All right, thank you. All right. Okay, I'm done. Yeah. Who's on deck? He's somebody on deck. He's somebody on deck.
I'm gonna ask you a lot of questions.
You're gonna ask me questions, sir?
Hey, David.
Oh, I can't wait. Can't wait for your questions. Where's the thing? All right.
Remember, you have a mask on, so you have to speak up, all right?
All right. So, my first observation is right here. It's a heat map, and I basically took like tweezers and had paper in between the tweezers, and I held it at different angles up to the candle to see how far away it would light. And from the top, it could light from like 2 inches away, so that's like pretty far. And then from the sides, like once you got to a diagonal angle, it was only about, what was that, 0.5 inches, so like half an inch away. And then from the complete side of the candle, you basically had to get it into the flame to light it. It was only about 1/4 of an inch to light.
Very good.
And then
Why do you think that is, that the top has
okay.
the farthest away and
So,
the sides have it close?
because the candle burns upward, so the fumes and stuff are going up. So when the fumes hit it and stuff, it can.
Have we thought about why the flame goes up?
But if the flame goes up, yeah.
If the flame goes up, doesn't that mean the top one should burn faster?
Yeah,
Burn, like, you mean burn farther away?
no, burn closer.
Yeah, burn closer, because you just said the flame goes up, so if the flame goes up, then the piece of paper on top should.
He's saying that.
No, I'm saying that, like-
Even further away, and
Yeah.
it's still hot enough up there to catch
Because
on
the
fire.
fumes. So like, if the fumes are going, if the fumes are going like up, then they're hitting stuff like up here.
Yeah, but like, why the flame
And,
burn?
can everybody understand, you don't have to know the answers, we're just talking about it, okay? But you know, wait, he's doing the right thing, he's doing the right thing. You don't have to know the answers, just, what do you think?
Oh, I think it's the fumes that are like hitting it. It's kind of like pushing heat upwards, so it's lighting it on fire. I don't know.
All right, another observation.
All right. So my second observation is number 14, and that is, I wanted to know if the wax was like a fuel to the wick. So I ran a test, and the wick with wax. So like the wick surrounded by wax stayed lit for 6 minutes and 30 seconds compared to just a wick itself with no wax, and that only stayed lit for 22 seconds.
How much?
22 seconds. So it was like 6 minutes more with wax.
What do you think about that?
I think that the wax like is kind of like fuel to the flame, so it like keeps the flame burning on the same thing for longer, so it doesn't have to like use as much of the
Okay.
wick at the same time.
So like the wick itself only burns for 20 seconds?
Yeah, just the wick by itself burned for 20
But
seconds.
the wick with wax, 6 minutes or something.
Yeah,
How does it-
6 minutes and 30 seconds. What?
No.
What are you saying, sorry? All right. And then so my second, or wait, hold on, let me see which one I want to do. Okay, all right. So my second experiment, or no, my first experiment was like kind of related to that experiment that I did with the wick. So we were told to discover like how a candle works. So I wanted to know of the two things that the candle's made of, which one burned, and which one like fueled the flame or whatever, or like what the other thing did. So I can't read it. Okay. So my first test consisted of lighting only a wick to see if it would hold the flame, and it did hold the flame. So I ran the same test with only wax, and it did not light. It only like melted away. So after these tests, my conclusion was that the wick was the thing that held the flame.
Yet the wax itself didn't burn. But on a previous observation, you thought the wax was the fuel.
Oh yeah, that was my second observation, or my second experiment. I wanted to see what the wax did.
Okay. Wow. You seem to enjoy this. That's good. All right, thank you, Rich. Next up, and I need somebody on deck.
Sorry.
And hey, you know what? If somebody else asks you a question, don't be defensive. Don't be defensive and say, you know, here's what I think, or I'm not sure. I'm not sure about that. Hi, Dave, what do you got?
Hello, fellow scientists. Behold my rough sketch of a candle. Simple observations. The flame burned higher and orange near the top, but blue and rather more hot towards the center of the wick. And a heated probe in contact with the candle made little, how do you say it?
Holes?
Yes, holes in the side of the candle. For my first up,
Oh, that wasn't an observation.
that wasn't an observation. That's just my
Okay.
thingy.
Oh, gotcha.
Yeah.
Good.
My first observation, a misty and damp residue formed on the inside of a Pyrex beaker as and after the flame lessened. The misty substance cleared shortly within 1 minute after the beaker was removed from over the candle. So basically the candle went out within 20 seconds of a large beaker being placed over it.
But after you took the beaker off, that fogginess or condensation disappeared.
Yes, within a very short
That's
period.
Another observation.
My second observation is that wax droplets that clung to the probe after it was dipped in the wax pooling below the wick seemed to be repelled by the flame as I prodded the wick, so to speak. It moved closer towards the hilt or farther away, depending on where
The specks were in the liquid wax.
No, no specks, just the wax droplets itself.
Oh, okay.
It appeared to move, shift. And an experiment I performed was I placed two objects over the flame so as to extinguish it. The first being the aforementioned large beaker, the second being a small sheet of aluminum that rested over the flame, over the indentation where the wax had melted around the wick. With the beaker over the candle, it took 20 seconds for the candle to extinguish, and with the aluminum piece, it took 1 or fewer seconds. I believe that is a result of the air present when the in the area that is cut off from the outside.
So you think the aluminum foil foil did what? What do you think the aluminum foil did?
Well, seeing as there was the candle, yes, and then an area of melted wax that kind of sunk down.
So you put it over there, and why
Put
did
it-
it go out in our way?
Huh?
Why did the flame go, why do you think it went out? You don't have to know, but
Well, I think a flame is only able to burn when exposed to much air.
so you think the aluminum foil cut off the air?
Yes, at a quicker pace since there was a
Okay,
smaller area of air involved. Thank you.
thank you.
Good job, Dave.
Okay, cool. All right, are we on there? Sally, don't forget to introduce yourself as a scientist, okay?
Is it frozen?
Oh, okay.
I don't know what to do.
All right, sorry.
Okay.
This is very interesting, okay? Keep going.
Okay, hello. My name is Carter Brecka, and I'm going to be sharing some observations and an experiment that I did during the candle lab. Okay, so my first observation is that when, hold on, I need to hold this. When a tiny shard of the waxy shell is held about 0.7 centimeters above the flame with tweezers, the wax shard melts at about 0.5 to 0.7 centimeters above, and the flame grows to be about 3.6 centimeters. The flame also gets a bit shaky.
Which one are you reading now? Can you
Number
read
10.
flat so I can look at it? Okay. When a tiny a shard, is that what it says?
Yes.
Shard of waxy shell is held 1 centimeter above the flame.
It's 0.7, or yeah, 1 centimeter.
Okay, 5 to 7 centimeters, okay. The flame would grow. And it gets a little shaky. Okay, good.
So like the wax that's being like dripped over as it's melting is making the flame grow, and it grew from like maybe 2
The
centimeters.
flame got bigger,
Yes.
and then what's the shakiness?
Like it started to like flicker rather
Okay.
than just stand still.
Okay, all right, next.
Okay, my next observation is I did the same experiment as Matthew, but my radius or like the heat circle was much like closer to the flame. So the heat radius varies between 0.4 and 0.1 centimeters, and this is when a small piece of paper is held at an angle of the flame and move closer and closer until it catches fire. So
Which one are you reading?
sorry, it's not on. Okay, number 20. So I drew.
So did you think it was a circle? Did it make a circle shape?
It
you
was,
think?
yeah, it was like growing more at the top. Like I could hold it higher above and it would catch
Oh, you
fire.
did, okay.
Fire. And same for like right here. It was higher or not as close, but
I see your
yeah.
numbers, 1, 2, 2, 4, what do they stand for?
Centimeters. They're centimeters.
Before what, caught on fire?
Before it like
Oh.
started to catch fire.
So, on the sides, either 1 or 2 centimeters, right?
Yes.
At 10 o'clock and 2 o'clock, it was what, 2 centimeters and 4 centimeters?
Mhm.
And above it was what, 3?
Yeah, but that could have also been like the flame. It was like moving a
Okay.
lot, so it could have just been closer to one side than it was to
Do
another.
you have any suggestions if somebody wanted to do this, to not let the flame move? Is there any way to, we done the experiment, not have the flame move?
I'm not exactly sure.
Why do you think it was moving?
I don't know. Well, when I put like the wax in it, it also made that made it
Oh,
move.
it did.
So, I don't know. It was like not magnetic, obviously, but it was like that. Like it was being
So it
pushed
did draw.
towards one side. So, I'm not exactly sure why. But
Anybody, suggestions? Do you think air moving in the room made the flame? Is that possible? Do we do the experiment like in we put in a cylinder or something like that? Maybe we did that. All right, experiment.
okay. Okay, so I
Choose
did
your
this.
experiment, we gotta go.
I put 15 milliliters of water in a test tube and held it above the flame at about 1 centimeter. After 45 seconds, it started to sizzle, showing the water was heating up. And after about a minute and 23 seconds, the water in the test tube started to boil and bubble up, and condensation collected toward the top of the tube. I did this to see how hot the flame could get to the point of where it makes the water boil or bubble.
So it was hot enough to boil water, wasn't it? We know that, right? And somebody might do a test and say, is it hot enough to melt this kind of metal? All right, so if you didn't talk today, we're gonna have our final element quiz tomorrow, and then you'll talk tomorrow. How about that? Okay, thank you very much. Thank you very much. I'm enjoying the science part of you. This is great.